want to make sure that we introduce who the executive judges are. We'll do that in just a moment. I want to make sure that you as a whole group understand what the twist is and what these groups have had to go after. The format of this is, excuse me, that the teams will present some portion of their time on their original case. So those of you that would have likely missed the others' presentations will get a chance to hear about their strategy. And then they're going to spend a portion of their time on this get twist here. So that'll make up the total presentation. The judges will have time to do the questions like you guys had, and then they'll be scoring and we'll move on. There's a couple of breaks in between. We got 6 this year. So we'll have a couple, we'll take a break, a couple more, a break, and then do 2 more, and then we're off to the rowboat. So get your paddles ready, yeah? All right, so that being said, what I would like to do is get the judges first introduced. So David, you could kick us off, that'd be great.
Sure. Hi everybody, I'm Dave Drulard. I'm the Executive Director for Indirect Purchasing, Machinery and Equipment at General Motors. Just to talk a little bit about what I do, essentially I have everything within the company that is not a part on the vehicle. So I have all the capital equipment, IT purchasing, advertising, consulting, and so on. So anyway, that's what I do for the company, and it's a pleasure to be here and meet everybody, and you guys are just wonderful participants. So thank you for inviting me.
Good afternoon, Bob Onska. I've been helping out with supply chain management programs in Wayne State for the last year, Professor Emeritus at Michigan State University, as well as being in faculty at Arizona State University, where I bring a lot of in-depth view from the academic side, as well as running research projects around the world with industrial firms. Pleasure to be here, and help on. I think this is my 5th year, so it's always been fun.
It is. Thanks, Bob.
Hi, I'm Darcy Scavone. I'm the Vice President and General Manager of Ryder's Automotive, Aerospace, and Industrial Supply Chain Operations. I've been with Ryder for about 10 years. Prior to that, I worked with General Motors, Delphi, a number of Tier 1s in the area. My background is primarily all automotive. I'm really excited to be here. This is my 4th year in attendance, and I'm always recruiting, so I'm looking forward to talking to many of you during the breaks. Thanks very much.
Good afternoon. I'm Bill Hurls. I'm the former supply chain leader, executive director for General Motors. I just retired on July 1st, but prior to that, I was responsible for all of our supply chain for our global operations around the world. So, and part of the founding group with Dr. Taylor, with myself, and Mike, doing this for the 5th year. So it's great to see it. It looks like it's been great competition. Looking forward to the presentations this afternoon, and I'll have a chance to talk to you this evening on the vote. Welcome.
Okay, the other thing I'd like to do real quick, and I know I'm taking time, but I can't help it. So I want the main case writers to stand up, turn around, just say your name right quick, and they deserve a huge round of applause, you guys. They would just stand up. Just quickly,
Jim Pressler, I'm with the Global Supply Chain Group at GM.
David Petrowski, I'm in the track program in GMCC.
Alice Lada, I'm in containerization at GM. And I'm in track program, Intelligent Engineering.
Ivan Shamami, capacity constraint analyst.
Tyler, still on the manufacturing.
Okay, thanks, you guys. And John, I'm going to have Jim read the twist. Do you
Okay.
have any comments if you need to make?
No, I don't.
Okay. All right, so we'll, Jim, if you would be kind enough to read the twist for everybody.
So this is what happens when you show up at places, you get asked to do that. So this twist is literally the nightmare scenario. We've got a supplier that supplies an assembly that has a pigtail harness on it that ships the part to the cockpit component supplier, so it's a sub-supplier problem. The team decided to have this cockpit assembled at the Tier 1 or at the VAA. The same component is at issue. The problem is not discovered until it gets to the Detroit Hamtramck assembly line, where they go to make the transmission connection to the cockpit, and it's the wrong connector. So the task of the students is, what are you going to do now, immediately? How are you going to react? And then what are you going to do in the long term? So it truly is a nightmare scenario since you're thinking about LCL shipments from Vietnam to wind up in Lansing, you got at least 30 days in transit and it's false. So that's about it. We didn't give them a great deal of details, just threw them a terrible rock. All right.
Alright, well, good afternoon, everybody. Thanks for coming out. We are the King's Competition Team from Bowling Green State University. My name is Brooke Barnes. I'm a senior this year, majoring in supply chain management and marketing.
My name is Paige Fitchler. I'm also a senior, and I'm majoring in supply chain management.
My name is Christian Craig. I'm a senior, majoring in supply chain management.
I am Trent Kaufman, a senior, also majoring in supply chain management.
And to start off today, just a brief overview. DHAM currently has a very active production plant, is a very active production plant, as we saw yesterday. A lot of complexity, as well as the CT6 launching at the end of this year. Just to add to everything that's going on up there. Just an overview of the current structure. We have a lot of parts coming into DHAM every day at different times. We're running some resequencing. And then moving forward with factors that we considered in our analysis, the first one being SBI and air quality. The JI facility being quite far from DHAM. New locations that being SBI and JI do not have the ability to expand their capacity if that would be needed. Additionally, the JI contract is up at the end of this year, so if we want to extend that contract or end it. And then lastly, the resequencing of parts at DHAM is just another thing that adds to the complexity at the plant.
So, in regards to the complexity, we felt that we had two options to solve this. Our first option would be to move the assembly of the EREVs from SBI or from JI to SBI. So one of the positives is that SBI is already large enough to handle the capacity, so we wouldn't need to do anything to their building or expand. And then it would save us $7,220 in labor each week because we would be paying lower wages. Similar, SBI has lower wages than JI, and we'd be able to consolidate some of our headcount by reducing the number of facilities overall. And also, because we'd be moving to only a mile away from DHAM, SBI already has a quick lead time, whereas JI does not, so we would be able to get rid of that aspect. One of the problems with this option, though, is that they do have many quality issues with SBI. We are worried if we give them more business, then their quality might get worse. And then we would want to be careful in giving them the EREV assembly because we would want those to be held to higher standards. Also, JI still has the contract for the components for the EREVs, so we would have to work around that if we chose to go with SBI. We'd still have to get the components from them, and then we would have to figure out where to source it from when their contract is up, so that would be some planning that we would have to do in the future. Our other option would be to do the opposite, and instead of getting rid of JI, we would get rid of SBI, and we would also move SBI or JI closer. One of the benefits is that JI has better quality, so we would expect the quality for the EREVs to stay the same, and also the quality for the sedans would improve because JI would be assembling them. We would still save some in labor, even though they have higher wages than they do at SBI. We would still be able to consolidate headcount by going from 3 facilities down to just 1. And then JAI said that they weren't willing to move closer because they didn't have enough business. So we are assuming that if we gave them the business with the sedans, that they would move closer. And also it gives us the ability to renegotiate their contracts when we're giving them more business and when we're not canceling it. The downside though is, as you said, since their facility is not close enough, we would have to move it, even though they're willing to. It's just additional planning and work that someone's going to have to do. And then we do have the risk of single sourcing if we're assembling both the sedans and the EREVs at one location. And this is just kind of a basic breakdown of what we're currently spending in labor and wages amongst the 3 And what we mostly wanted to point out was this number, because in our options, we're going to show how we're reducing that with the overall spend.
So now we're going to look at the costs that go into these options. Starting with labor, we calculated labor with SBI by consolidating managers from going to 4 to 2 with the 2 shifts. And then also with SBI, we'd add a quality manager because due to their quality problems. And if we chose option 2 with JAI, we'd also consolidate managers. With transportation, we with SBI, it'd be a higher cost due to JAI sourcing the EREP component still, and also M&M sourcing, and also M&M going to SBI and SBI going to DHAM. Well, we're assuming that JAI will choose a new plant closer to the DHAM location and be this one direction. For the capacity, SBI would add a line just for the cost of $250,000, and then if we move JAI to a new facility, they have to move 2 lines, in which we assume the cost would be $500,000. The quality issues would be unquantifiable with SBI down the road. We're not sure what the safety cost would be due to these quality issues that they had. Well, with JAI, since they're high quality, we've seen a decrease in the amount of spend that we would have if we chose them. The one-time, we're assuming JAI would have a one-time cost for the person in the building due to us giving them more business in after our calculations, stating that they'll have a 134% increase in revenue, while SBI has 74% increase in revenue if we chose that option. Our decision ended up being JAI due to the better quality, and obviously, as you can see, the less complexity, they just simply go to JAI to DHAM with their new location.
All right, so after tackling the first issue of simplifying the already complex supply chain, we decided to move on to how to deal with the capacity issue for the assembly of the new Omega CT6. So with that, CI has already been awarded the contract for the components. The only issue we really have from here is where to assemble these cockpits at. We have 3 choices, CI, SBI, and JAI. However, because we eliminated SBI previously, we decided to weigh our options between CI and JAI. So again, pros and cons. Our first option here would be expanding at CI. Some of the advantages start off with the higher quality that CI ensures. They already also have the contract with the components, so assembling the cockpits in-house will also add some efficiencies. We only have to worry about sending the cockpits to DHAM instead of worrying about sending components to JAI, and then from there JAI going up to DHAM, so we would only have 1 trip. CI is also already used to the newer technology because they already assembled the cockpits with the Cadillac ATS and CTS, which are similar with the technology in the CT6. Again, they've seen this and they're ready for it. And lastly, CI has already been willing to allocate some of their current capacity toward the assembly of the CT6 cockpits. Moving on to our disadvantages and negatives, we would incur a longer lead time because CI is in East Lansing. It's going to take longer to get to Detroit compared to a supplier that's already in Detroit. We would also have resequencing issues at DHAM because CI will be shipping to DHAM as well as JAI shipping to DHAM. The different parts come together. At DHAM is going to need to be resequenced. CI does also charge a premium because of their quality and their reputation. They're able to pass that on to their customers. Lastly, they do pay higher for labor and so they provide higher wages. Our second option would be moving a line to JAI to assemble CT6 cockpits. Again, some pros and cons here. The advantages start off with a lower cost. They have less wages, their wage costs, as well as they wouldn't have to, or we wouldn't incur a premium. So, like I said, CI charges a premium because of the reputation. JAI does not. Moving on to our cons. They do have lower quality than CI. They also are still going to need to obtain the components from CI, so again, since CI has the contract with the components, the components will be shipped to JAI, assembled, sent to DHAM, adding in the complexity of transportation costs and, again, just the complexity. And they also do not have the experience like CI does with the Cadillac cockpits. So weighing the options back and forth here, going off for labor, so we would obtain a cost savings in labor because we would only need to add 3 assemblers to deal with the additional capacity, as opposed to expanding at JAI, we're going to need to add 4 assemblers. Transportation-wise, again, because it's going to be streamlined going specifically from CI to BM, it's going to be much cheaper and will obtain substantial cost savings there, as opposed to the shipments going from CI to JAI up to BM. And lengthening the current line at CI is only going to cost $2.7 million, as opposed to adding the full line at JAI. The additional capacity and tooling is going to come out to $5.5 million. With the capacity already allocated toward the CT6 cockpits at JI, we figured they would have, we would only need to add 70 containers with a cost of $71,260, as compared to the returnable containers we would need to add the full amount at JAI, coming to a total of $117,070, both of these being a one-time cost. Lastly, we are going to need a new material sequencer at DHAM for both options, so this was just something we put into consideration and figured we'd put on the slide as well. So lastly, our final decision is to go with CI here at GM. We love saving money and love having good quality. So with this, we're going to save money on our labor, tooling, transportation, as well as the container costs, and we'll be able to obtain better quality with going with CI because of their reputation. And again, this Cadillac CT6 is the first to be unveiled out of 8 in the next 10 years, so we want to make sure that this Cadillac meets these standards and expectations set for it, again, being the reason why we went with CI.
Okay, now moving on to the twist that we were presented with earlier today. For our short-term solution, we would like to have a quick response team assembled to oversee this issue, seek it through, make sure that we have everything ready. For doing this, we want to find a domestic supplier. This would lead to shorter lead times, so we don't have to wait however many days from the product to get here from overseas. Also, an expedited PPAP for a temporary substitute of the part so we can get production back and running. And then for the costs, for the price difference in the product that we would source temporarily, CI would have to incur that cost just because it is their supplier, they're responsible for procuring that, that is our issue. And then for the freight premium, having to get these shipped, we decided that we would share that cost, not knowing what the contract spells out as far as who would incur that. We decided that we would share that cost.
So now that we took care of the short-term solution, we have to consider long-term what we would want to do. So we really have 2 options. We can stay with our current supplier, or we could find a new supplier. So if we stay with our old supplier, we wouldn't have to terminate the contract. So that would be a positive. We wouldn't. I'm not sure if there would be any fees with that, or if we would have to stay with them partially while we slowly move to another. And then so CI already has familiarity with that supplier, so they're already used to how they do business and working with the people, so there's that. And then it's already approved supplier, so we wouldn't have to go through the process of getting another one approved, which can take some time. The cons, though, is we do have a risk of the quality issue repeating itself. We weren't really given much information as to how the quality problem came about or why it's not fitting now and it used to. So if they were trying to cut corners or if it was just a one-time problem, we're not really sure, but it could happen again. Another con is that there is a long lead time that's 30 days because it's coming from Vietnam, and also it makes it very unflexible for any planning changes. We have to know quite a ways out if we're going to make any alternations.
So for option 2 of finding a new supplier, we did another list of pros and cons. With a pro, this would be an ability to renegotiate a new price and quality. We could possibly get a newer price or better quality with this new supplier. Also, we could find a closer supplier, which could lead to less complexity and also shorter lead time. A con is that we'd have to reapprove that part and go through a PPAP process and maybe like a test run of these parts, and we're not really sure how the quality would be on that. Also, Another con would be we'd have to cancel the contract with the old supplier. And also getting the new supplier approved along with canceling the contract. We're not sure the amount of time this would happen in the short amount of time that we're given.
All right, so for our conclusion for the long-term twist, we decided to stick with the incumbent. We feel it would be more advantageous for us to stay with them because we wouldn't have to worry about approving the supplier as well as the part with somebody new. And we feel that they are capable of providing the quality products because CI has faith in them. And again, we don't necessarily know for sure if this is a reoccurring situation or if it was just a one-time fluke. We think that assuming it is just a one-time fluke, we could work with them, get this resolved, and keep moving on from there to get the best quality for our CT6s. So from that, we can open it up to questions.
So maybe I'll start it off. Could you maybe go a little more in depth and elaborate on how you would resolve the immediate production issues that we're having with the CT6 and the fact that they are not making vehicles? I'm not sure I understood your solution there.
So we're not really sure about the part itself, so we don't know if this is something that is carried in stock places or if it has to be made. So we thought that if we found a domestic supplier that was close, that we could get the part right away. And so because they said that they couldn't fix it on the line, they didn't have the room for the quality fixes, we'd have to first fix the ones that are already bad while finding a close supplier to get the new parts, because with the 30-day lead time, you know, we can't have the line down for 30 days. So even if the supplier from Vietnam fixed it the next day, it's still going to take us 30 days to get it. So not knowing exactly how to fix the issue, we would just have to try and find a supplier that was close.
Good job, good presentation.
Thank you.
In your recommendations, I think, Paige, you had made the comment in the pros and cons, is you compared quality. You know, you compared the two suppliers. And I think the assumption was that bringing on the added volume to your good supplier will probably make the quality better. Is that how I read that?
We assumed that we would hope that the quality for the E-revs would stay the same, because we're gonna be we're bringing up the head count, so we're not putting any more strain on the workers that we already have, and we're adding a line, so we're hoping it won't interfere at all with what they're already doing. So what we meant by increase is that the sedans quality would increase, because now JAI would be assembling them instead of SBI. So overall, we would hope that our quality between the two would increase, whereas if we went the other way with SBI, they already have quality issues, and then the E-revs, which they would now be assembling, would get worse.
Yeah, that's one of those assumptions you want to be careful with, because in some cases added volume can actually deteriorate. So some of the steps you just mentioned are good answers. You want to verify. You made an assumption based on this, but it's something, and you do mention you'll go back through PPAP, which you need to do, which is good. The last question that I have is, the way the twist is written, you basically assume the problem is with the connector being provided as part of the cockpit assembly. What you didn't mention in there was, are you sure it's not the other piece of the connector? And that's kind of, and you know, being in the industry, we're kind of used to that. But one thing you always want to check is to make sure you've isolated what the real problem is. Because in any connector assembly, in this case I think it's the transmission that it connects to, it could be the male or it could be the female connector that's actually causing the problem. So one of the steps in your verification needs to be, we need to identify, is it truly this connector, or is it the mating part? And you don't want to do anything, you don't want resource or anything like that, if in fact it's the other half. Okay, good job.
We did try to Google what it was, and we didn't really get great answers. So we were a little.
Consider a receptacle on the wall.
Oh.
It could be the receptacle, or it could be a connector. Yeah.
I have two questions, one short-term, one's long-term. What did you see, or did you discuss what you thought the biggest financial impact on the company would be because of this product, that would be GM. And did you assume that these lead times of 30 days were fixed and couldn't be altered? This is short-term question, I'll come back to that.
Well, I know we did assume that, we did assume that the lead time was just at 30 days, so that is how we based on our assumptions. And then with the short term, I would say the biggest financial impact would be all of the obsolescence of the parts. We don't know if we would have to incur the cost or the supplier, because they already have shipments on their way. So, I mean, do we have to incur the cost of the scrap, or does CI, et cetera? So.
What about this whole issue of being able to make vehicles, produce vehicles? If you can't get the mating of the parts together to work, you're not going to produce the vehicles.
Right.
So if you don't produce the vehicles, you can't sell them.
Right.
So it's going to affect the financials.
Yeah.
I think that, and also kind of going off of this would help, expediting the shipments for the short term, you know, like you said, having vehicles down obviously is not a good thing, so expediting the shipments of that component to get the line to run as fast as possible, again, could be another big financial toll we have to take.
Certainly, you know, the auto industry has a history of, you got a problem, fix the problem, and airship everything, whatever it takes to keep producing vehicles. The other longer term question is, you have this problem, and it's causing you some negative consequences. What would be the long-term approach that you might take with regard to this issue? These things didn't make it, so you couldn't produce. So what would you do long-term?
We were under the impression that originally, from how we read it and how we tried to analyze it, was that they were fine at first and now they're not working. So maybe we misinterpreted it. But so we're assuming that the old supplier has the ability and the capability to produce the parts that do work and match up, and that we thought it was just something came up, whether they were trying to cut costs, cut corners, or just being lazy or whatever, and now all of a sudden the parts aren't matching up, or maybe their machining is a little bit off, so they're not mating together right. So we assumed that we could take steps to fix the quality, and that it wasn't like a permanent thing that they never mated. So we did kind of assume it was their end, not our end.
Sure, probably the only thing I'd add is this issue that has to be really examined in detail so that we'll prevent this kind of point that you're suggesting. It doesn't have to be. So you have to understand all the consequences. Very good, thank you.
Okay. All right.
All right, well, thank you for taking the time to listen to our presentation. We're very excited to share with you our CT6 sourcing strategy. To introduce myself, my name is Jade Gunderson.
I'm John Feidinger.
I'm Evan McLaughlin.
I'm Travis Olson.
All right, so we'll get started. First, we're going to go over our proposal from yesterday, and then we'll go into the crisis twist. So first off, we'll start off with the project description and objectives. Our task was to create, evaluate, and implement the sourcing strategy for the Cadillac CT6 high-tech cockpit. Through that, we assessed the most effective and beneficial opportunity for General Motors. We identified and proposed a solution, as well as developed a detailed cost analysis for that. So basically, our main objectives, first and foremost, was to improve the image of the Cadillac brand. And how we did that was to consider quality and prestige of brand. Through that, reducing cost, as well as simplifying the complexity of the supply chain. And then finally, choosing a supplier in which a strategic sourcing strategy and strategic relationship was going to be formidable. So just a quick run through of the CT6. Most of you already know, production's at Detroit Hamtramck. This is a completely new platform in the GM family with many new technologies. There's a lot more components to this vehicle than other vehicles, and it's more high tech. So our objective here was to design systems that deliver near perfect quality at the lowest possible cost, as well as ensuring that those tooling capacities could meet marketing's projected volume of 500 vehicles per week for the Omega CT6. So the Cadillac's ultimate expression of safety, comfort, luxury, and connectivity. So here are our strategy opportunities laid out for you in this table. We have 4 options. The first for the Omega CT6 is to assemble the CT6 at Sakone International, or the alternative would be Silver Bullet Industries, further referred to as SBI. And then upon reading the case, we determined that the contract was going to expire at Journey Automotive Industries for the EREVs. So this is a prime opportunity for us to either re-up that contract or move that product to a different assembler. So the options for that are move it to Silver Bullet Industries or leave that at JAI. So the supplier selection criteria in which we evaluated these suppliers: first off, quality, the assembly of the vehicles and the components, and the quality of the operations. And then there's transportation, which is the delivery of the components and cockpits, logistical efficiency, reducing cost, of course, and then capacity. So is this assembler going to be able to meet the demand for the vehicle? So the first supplier we have here, CI, is a tier 1 supplier. So the important point to note here is that the superior quality reputation. They have been assembling these cockpits for over 100 years, so the quality there is up to par. They're located 89 miles from DHAM, which does pose logistical challenges and opportunities for those sequencing times to not be met. They have current capacity for 200 cockpits with availability to have the 300 additional to meet that 500 weekly demand. They're currently producing the ATS CTS, and this is very advantageous for us as there's similar technologies to the Omega CT6. And that does simplify operations then. So with this option, CI would procure, produce components, as well as assemble those cockpits for the Omega CT6. Second supplier we have is Silver Bullet Industries. Important point here is that this is a third-party value-added assembler. This is 2 miles from DHAM, and that does have less lead time, and that helps with those sequencing times. They have capacity to meet demand for the CT6 and EREV. Currently, they are experiencing some quality problems. They have put in methods. Those quality problems have led to assembly line downtime as well as cars being held in the repair lot, but they have invested in error-proofing system as well as process audits. So they are improving, which is very good to see. And also what's important to point out is the CT6 does have significantly higher content, like I said, with the components and the high tech than in the current SBI assembly. So this has added complexity to their assembly. So first off, just a capital run through of each option. So option 1, we have the CT6 at CI. This is a cost of $2.7 million, and this is the cheapest option for producing the CT6 based off capital. And then to move the EREV line to SBI would be a small cost of $250,000. This is the lowest total cost option, just under $3 million. The second option here is the CT6 at CI again, and then as well as leaving the EREV at JAI. So leaving the EREV there, the cost is already incurred from the previous contract, so this option is just $2.7 million. Third option, moving the CT6 to SBI, and then moving the EREV to SBI as well. So producing both of these vehicles at SBI would give us a capital discount of 5%. However, producing the CT6 at SBI is quite costly at 5.5. So this is a total cost of just under 5.5 million. And then finally, the CT6 at SBI and leaving EREV at JAI. Like I said, JAI's cost is already incurred, but this is the most expensive option at 5.5 million. So now I'm going to hand it off to Evan to talk about production.
Yeah, so now I'm going to talk a little bit about DHAM, which is a very hectic facility right now. All the cockpits will end up there and be assembled in the production line. And this is our trucking options to get them to from our supplier and from our suppliers to our production facility, and then ultimately to DHAM. And you can see we use Supreme's trucking or Quattro Logistics, and Supreme's is using a dedicated trucking line, whereas Quattro is quite a bit cheaper. So we decided to go with Supreme's because we need someone we can rely on for quality in a just-in-time inventory system. We need somebody we can count on to be reliable, and a dedicated trucking line is what will give us that option. And now I'll hand the floor over to Travis.
All right, thank you, Evan. So I'm going to talk a bit about the really important part here, which is the component aspect of this project and the transportation flow that we're going to need to use. If we do decide to assemble the Omega CT6 cockpits at SBI, we are going to have to follow this flow just like the EREV options here also if we assemble those at SBI as well. So starting with the CT6, at Saucony International, as was mentioned before, Tier 1 supplier, high quality. They produce and procure all of the components, so we would still be getting all the components for there. However, they then would be transported to M&M Industries, where they would be deconsolidated, repacked, and reshipped. And then they would end up at SBI as their final stage and the point of final assembly for the CT6 cockpits. Same kind of flow for the EREV. However, these ones will start at JAI, as that's the Tier 1 supplier there, and they also produce and procure all those components. Would still go to M&M to be deconsolidated, repacked, and reshipped again, and end up at SBI as the final point where those cockpits are going to be assembled. And when we take a look at truck optimization, we just talked about those components, but really critical on how we get those into trucks, since we're dealing with a very large amount of components here. So we optimize this using a 10-day trucking delivery schedule. And basically, we used a linear programming model for this, and that's what gave us the best distribution between these trucks.
Back at it.
Go back one.
Oh, sorry.
All right, to continue. So we use some linear programming here to standardize this process. And it is a standardized process, so we plan these schedules out for 10 days of truck shipping here. So as long as this process is continued, this will continue for the remainder of the program. Like Evan mentioned, we use 53 standard trucks here, and we constrain those to volume and weight limits. So with the volume limits there, we have all the trucks not exceeding 87.5%. That gave us the best balance between the EREV and the CT6. And some more about the truck loading too. For the CT6 components, that truck shipment is going to deal with CI to M&M. So that was optimized for 4 trucks in that situation. That was with that 87.5 loading constraint. And back in the case, it talks about the reusable containers that we need to use. So we calculated based on that 4-day lead time that it was going to require 703 cases for that option. And then moving to the EREV option, that trucking dealt with JAI to M&M. Loading, we optimized using that linear programming there for 6 trucks. However, with this, we can save some costs because since the volume is cycling with the different requirements for the components there, about every 7.5 days of the program, we can eliminate that 6th truck. And for those reusable cases, again, it was about 1,024 that we calculated with that 4-day lead time. All right, I'm going to hand it to John here.
I would like to talk about production and transportation of the Omega CT6 cockpit. Because DHAM is limited to sequencing 40 cockpits an hour, we used a linear programming model to figure out how many of each vehicle can be produced each hour. And staying under the 40 an hour, and also being able to meet our demand. Every 2 hours, DHAM sends a signal to the assembler of how many Omega CT6 exit the paint shop. Once the assembler receives that signal, they start production. We figured out how long production is by taking the total amount of daily demand and dividing it by 14, which is the hours we determined to be in operation. We also added weights to the employers, to each shift to account for the number of employers working. And once the cockpits are finished, they are shipped to DHAM, and we determined that you need 112 for CI to account for the 4-day lead time, and 28 for SBI to account for the 1-day lead time. The total cost of the Omega CT6 at CI would be, the total cost of the assembly of the Omega CT6 cockpit at CI would be $585.8 million through the life of the program. The assembly at Silver Bullet Industries would be $259.2 million over the life of the program. The total cost of assembly of the EREV at JAI would be $785.8 million and at SBI it would be $388.8 million over the life of the program. Now I'd like to hand it off to Jade.
So the exciting part is our proposed solution. We did choose to option 1. So this is assembling the CT6 at CI. The reason we chose this is that they are a tier 1 supplier. So in order to make a proper strategic decision for the life of this program, we needed to consider quality at the forefront of this option. Their quality assembly is going to improve the image of the Cadillac. We're very confident. SBI does have operational inefficiencies and quality control issues, so to hand them the CT6 and be confident in their ability to produce it, we just did not feel like that was feasible at this time. And assembling both brands at SBI would result in max capacity there and probably likely lead to operational inefficiencies. So to move the assembly line to the EREV, or assembly line of the EREV to SBI, that's a low cost of $250,000. They are also located 2 miles from DHAM, so the simplified sequencing is going to give SBI an opportunity to improve on those operational inefficiencies. And so while they are doing that, we're going to monitor their quality improvement for future business. So if they're doing well at the end of the 6 Life program, then we can handle them with another brand of vehicles. And just looking at the cost analysis of this option, you can see that the majority of the costs go to component cost as well as cockpit assembly. So if we're going to have a quality vehicle, that's likely where that capital cost is going to go into. So it's important that we consider quality. And this option is just under $900 million. So now I'll hand it off to Travis to talk about our implementation plan.
Yep, so there are some risks with this option that we chose, and just to go through these, there is a long distance between CI to M&M and also from CI to DHAM, and you know, we're from North Dakota, we know all about what bad weather is, so those are always going to present some delays in the shipping. So that's something that comes down to the logistics coordinator, always making sure those trucking schedules are adjusted accordingly just to always meet production requirements. Another one, the component bill of materials, that's for exact usage per part. So if some of those bolts and screws are being lost, parts are being damaged, more are going to have to be ordered. And as long as we're always ordering components by requirements subtracted from current inventories, we're not going to run into this issue. We're always going to have the right amount of parts needed. And lastly, moving the EREV cockpit assembly line to SBI. We know SBI has had some quality issues. We're confident, though, that they have installed the right measures to prevent these in the future. However, if some of these issues were to rise again, we would make sure that our contract is structured so that that responsibility is passed off to SBI to ensure quality. And for our decision here, the Omega CT6, this is a huge brand for Cadillac, or a huge new vehicle for Cadillac. And we know and we're very confident that selecting CI as a supplier is going to improve the Cadillac brand. It's also going to improve the prestige of the brand. And really, when we left DHAM yesterday, I think we all left really understanding more about the Cadillac CT6. You can read about this as much as you want in the case, look up pictures online, but being able to see it, it really makes you realize that this car, this vehicle, demands quality, and this brand demands quality as well. And choosing to source the cockpit, or choosing to assemble the cockpit at CI, that meets that demand.
So here we're going to talk about our case twist. So we have a 5-point action plan that we have developed. Just as a run through of the case twist, the transmission indicator harness relay connector is not mating to the transmission harness, and that connector is a purchase part. It's not produced. So vehicle production has currently been stopped, and that problem has been being found in all CT6 cockpit assemblies, as well as the inventory that we have right now. So the supplier for CI is called T2, and it's located in Vietnam. Currently, their parts are shipping for these modules once per week, LCL with transit time of 30 days. So manufacturing lead time is unknown, so expediting is crucial, of course. Just when we're getting to the good part. It was. There you go. Okay, so we're going to start with our immediate action plan proposal.
Okay, so implementing our action plan here, we're going to make sure that we carry out all these options just to make sure that that critical timing is still met here. So the first thing we're going to do, and we're going to have to pull this CT6 out of the line immediately just to ensure that all the vehicles are still being produced, because that downtime of the CT6 not being able to get those components in, that's really detrimental to the execution for all the other vehicles at GM. And we're going to pull that vehicle, out, the CT6, out of the line, and we're going to put that in the repair lots just so that's off to the side so we can keep doing the other production. Second, as we learned yesterday too, all the Tier 1 suppliers at DHAM, they always have a representative there. So we're going to be reliant on that CI representative to communicate immediately with T2 in Vietnam to check on a solution and see if there's a fix to that problem. Third, if there is a solution, then we need to meet that 500 demand. So we're going to need those components manufactured expressly and shipped expressly as well. So we kind of researched the Vietnam market a little bit here, and we know that the largest airport out of Vietnam is Ho Chi Minh City in Saigon. We have the most options and the most access to major air carrier markets for our transportation of those components. So some of the carriers there, FedEx, China Airlines Cargo, Korean Air. FedEx we felt was the best just because they have a big presence there and they also have a very large presence here in Detroit. So taking a look at the lead time for shipment, our best case scenario, we could get those parts in 1 day on that flight. Worst case would be about 3 days for the air transportation time. And then also there is a lead time of about 1 week just in manufacturing and shipping all those components together. Also CI, we're going to want them to be communicating with the engineers at T2 and also in the area around CI. We know that CI has all these components in their stock currently, and those components we can't use right now, but if it's possible to get those fixed, we want an engineer in the area over there, or we want CI to send an engineer, or we want T2 to send an engineer up from Vietnam to take a look at these parts and make sure that we can get them fixed if it's possible. Also, while all this is in progress, we're going to take a look at some other Tier 1 suppliers in the area, just in case there is an issue with this plan. If we can't get all these components in, we're going to make sure CI is communicating to other Tier 1 suppliers. We know very well about Delphi. That's one that procures all these components, and that would be a supplier that we would really trust. That would really make sure that we're getting those all the components in to meet that 500 weekly demand.
So like we said, main objectives here are urgency. We need to get this handled right away and effectively. So we need to minimize the amount of downtime for that assembly line. We need to get the CT vehicles back in production as soon as possible. And we also need to minimize that lead time to receiving the correct modules so that we can get those running in the cockpits and get that back into production. So the urgency and prioritization is that main focal point. So execution of this vehicle is key to its success, so we need to get it back in production. Like I said, the crisis mitigation plan, we need to turn this crisis situation into an opportunity. So this isn't a problem, it's not an error, it's something that we have an opportunity to develop and improve on our production process and risk mitigation. And like with a new brand or new vehicle that we're producing, we're likely going to run into issues like this. This isn't much of a surprise, so it's just important that we handle this urgently and effectively. And like I said before, that strategic relationship that we have with CI is critical. That trust and communication will help us partner with them to effectively handle this as quickly as possible. So long-term speaking, T2 is express manufacturing and express shipping those correct modules over so that we can get that weekly demand back in place. T2 will need to implement, we're going to pass down that command to CI, but they need to implement process audits as well as quality management processes so that things like this don't happen in the future. And then finally, developing a proactive action plan for the future. So if issues like this do arise with additional parts in the CT6 or even other vehicles that we produce, that we're ready to go in there with our contingency plan. So CI needs to make sure that they're checking on the quality and assuring that those products are being procured effectively. So this is a great quality management plan for our team, and we'll make sure that they're on board with this, but we are very confident and effective that this is the best five-step action plan for us to get this crisis mitigated as quickly as possible. So thank you. We'll take any questions now.
Before we do that, I'm going to have you guys answer in that mic so I can get the questions on this mic here. We only have one. It's a corrective action for next year, so we're
So I guess I get the first question. Hey, so I think you guys did a great job and really hit on a lot of things that we as the GM team talk about when we start missing production and missing vehicle builds. So congratulations on that. You really did a nice job. I think my only question is in regards to the premium freight. Any thoughts in terms of who's responsible for those costs?
I think we would assume that CI would be responsible because it is their supplier, and we have a contract with CI, and so therefore in the contract I'm assuming there's probably terms that says if their procurement doesn't fill our standards and the standards we agreed upon, then they would be responsible for making up the costs.
Great answer.
First of all, I really like that you picked up on the fact that a lot of the vendors have engineers at the DHAM facility. That was a good use of that fact that you discovered yesterday. The question I have for you is, so the launch of this vehicle is so important from a quality perspective, and Cadillac is really trying to reposition itself to compete with BMW and Audi and so on and so forth. What external communication do you think might have to happen, because the cars are now going to be delayed getting to the dealer, and it's something that you would think from a public's viewpoint might be kind of like a Dick and Jane issue, right? The connector didn't work. How did that happen? What do we do with that?
Yeah, I think the first process is to evaluate the timeline that we're going to get those vehicles out. So is it 2 days? Is it 2 weeks? So like I said, we wanted to get this fixed within a week if that was possible. But the effective communication is we want this car to be as great of quality as we can make it. So we're going to need a few extra days for that. And we apologize, but that's what it takes to make a quality vehicle like that.
Do you think you might come out and say exactly what happened? That there's a supplier part that's defective, or what might you do? There's been a lot of this kind of
Sure.
press lately with recalls and things going on, and I think there's been some good uses of communication and some not so good uses of communication.
Well, I think it's important to be honest, but at the same point, not alarm them and just say that we're trying to enhance that connector so that it is the most effective piece that we can put into the vehicle.
Good job, thank you. Couple questions. First on the original business case, and I think Travis, as you were talking about transportation in the what you be it from North Dakota, what you encounter for weather and stuff like that. And that's a little bit of dilemma now, having the supplier farther away. In your chart, I believe what you said is you'd pursue some other mitigation strategies. What were you thinking about as possible other alternatives to de-risk that situation?
Yeah, so I know you guys get almost just as bad winters here too, so but we would make sure that it would come down to scheduling of when we're going to get those trucks in. So that would just have to be something that would be monitored, by weather forecast or something like that, specifically with the weather. But a contingency plan, we would just need to make sure we were on top of that, because trucking schedules can be adjusted pretty easily. And really, since we're not doing this driver bid system, there's going to be a lot of other trucks available. So we could have 2 trucks come in or more trucks come in at a next rotation, just to make sure that we're getting enough orders in there.
Yeah, one of the challenges we run into, especially with a commodity that's sequenced, is in some cases you don't have a real wide window that you can expand to put different trucks or additional drivers and stuff like that. But thinking about that risk was a good catch, and it's an important one, because as close as Lansing and DHAM are, I think it's maybe a 90-minute drive. We do encounter a lot of weather there. In the twist, and this is a point I made to the previous group, I liked your analysis. I liked your corrective actions you were taking. The sense of urgency is really important. One observation that you want to make sure you include in that is the fact that you've got this issue with this connector. It's a male connecting to the transmission module. As I read the twist, it wasn't clear which connector was really the problem. You really got a male and a female. So part of that analysis, one thing you want to make sure you include is make sure you get to root cause, because what I liked is how you engage the engineer on site. They're going to be looking at the 2 connectors, determining is it really the one from T2 that's the problem, because it could easily be the other part, right? And so the fix may have to take place with a different supplier, or the other supplier may be part of the solution in the end. But the action plans you were taking, getting those people involved, really, really nice work, you guys.
Thank you.
The only other thing I would add is, coming from the other end of this, right? We've been on the wrong end of this a couple of times. I really liked the thoughts of don't waste a crisis. My predecessor said that when we had an issue with Toyota where they shut a plant down, and we had some time to think about what we were going to do with our assets and our resources. And then also that you chose to partner with the supplier on collaboratively figuring out a solution too many times. I think we get excited and emotional when something like this happens, and the suppliers really do want to do the right thing, and cool heads typically prevail. So very nice job.
Good afternoon, gentlemen and ladies. We are the team from Wuhan University. I'm Owen. So here is our case presentation. Now, when we consider about how to create the supply chain for the CT6, the components, we need to consider about the quality, cost, and the complexity of this supply chain. So our thinking process will be presented into these 5 parts. In the first part is introduction parts. We will present 3 flowcharts to you to tell how the supply chain worked, and then in the calculation analysis, we will present the calculation appendix, and in strategy analysis, we will present you the how we need to consider about quality, reliability, and bargaining power. And then we will draw a conclusion, and then we will bring up some ideas about improvements, about how to improve our supply chain, and we will try to figure out how to deal with the new situation. So let's begin with the flowcharts. Here is the CT6 supply chain. As you can see, the Tier 1 option is on the left and the VA option is on the right. And the second flowchart is for EREVs. So it's similar to the CT6. So, and then the third flowchart is how the assembly line works in the DHAM. So as we can see, when a car goes through the body X, a signal will be triggered, and the JAR will receive the signal, and the lead time is about 217 minutes. And then when a car goes through the paint exit, a signal will be triggered to the SBI, and the lead time is about 120 minutes. The table below is about time such as the unloading time and the staging time. So let's move on. It's about calculation analysis. So how to calculate the cost? So please.
Now I will show you the calculation analysis. First, let's move on to Tier 1 option of CT6. First, we can divide the course into several parts. The first part is equipment investment. When calculating equipment investment, we apply straight line method to calculate, and the capital discount of each year is 5%, and the life cycle of each program is 6 years. And go on. Cost of containers. We use 100 CT6 cockpits a day, and each cockpit takes up for a quarter of container. And we have to stay containers for 4 days at the supplier, and for 2 days at the supplier and 2 days at the plant. So there will be this one. Finally, components and assembly fees, because CI quotes 4,068 for a finished CT6 cockpit. So we can draw the component and assembly fees. Labor cost of DHAM, because CI transport only CT6 to DHAM, therefore we don't need to sequence, so the labor cost of DHAM is 0. Inventory carrying cost. We suppose that average inventory is 50 cockpits, so inventory carrying cost. Transportation cost. After our calculation, we found that we only need to transport one time a day, so the transportation cost is this, and CI is 88.7 miles away from DHAM. Therefore, total cost, we sum this cost up, is 587 million. VA option calculation process is very similar to that of Tier 1 option. Equipment investment, cost of containers, component content investment, it's calculated from the BOM. And the component procurement, assembly fees, SPI quotes for 1,800 for each assembly part of CT6. And we have to take transportation expense into consideration. We can divide it into 3 parts. The first part is from CI to M&M. And after our calculation, we found that we have to use 4 trailers to deliver that quantity. The second part is from M&M to SPI just 1 time a day. And the third one, we found that the time is in a nearly normal distribution. Its mean is 33, and its standard deviation is 3 multiplied square root 2. So under a 95% service level, we found that it takes almost 40 minutes for loading, unloading, and logistic time. So we only have 80 minutes. Use 120 minutes minus 40 minutes. So we only have 80 minutes for us to receive signals. Thus, we have to transport 14 times to finish we have to transport 13 times to finish CT6 from SPI to DHAM. So the total cost will be this. And the labor cost. Labor costs we are calculated based on that of Malibus and Impalas that given from the Excel. So our total cost of VAA option is 559 million. And the EREV calculation process is quite similar to those of CT6. So we can find that for tier 1 option of CT6, the total cost is 587 million, and for VAA option it's 559 million. For EREV tier 1 option, it's 735 million, and for VA option is 736 million. So we can find that tier 1 option of CT6 is a little bit expensive than VAA option, and for EREV, VAA option is more expensive than that of tier 1 option. So after our calculation, let's move on to strategy analysis. Thank you.
Thank you, everybody. My name is Lily. In the following process, let's conduct strategy analysis. Let's start from the quality management. According to the graph and table in the case, we can make a conclusion about the mean and square deviation of the ppm of every assembly supplier. And we can know that if assembly supplier has greater mean and greater square deviation, it will definitely has worse quality. So in conclusion, we can find that SPI is not an appropriate supplier for us. And reliability is another important factor of the functioning of supply chain, because supply chain risk uncertainty can cause severe repercussions, and we can judge reliability based on 4 aspects. The first one is the reliability of suppliers, the credibility of suppliers, According to our case, we can find that CI is well known and GI is another tier 1. So their credibility is better than SPI. And the second aspect is the reliability of supply. We can calculate the average time of loading and standard deviation time of loading and deviation time of transportation. And we'll know that if the deviation time is longer, it is less reliable. So we can conclude that SPI has the best reliability of supply. And the third aspect is service reliability of suppliers, but we have no information about this. And the first aspect is the reliability of quality. According to the quality management above, we can find that the reliability of quality of CI is the best, and SPI is the worst. So we can define the best is 3 point, and the moderate is 2 point, and the worst is 1 point. And let's sum them up. We can find out every supplier's the point of every supply, and we can find the reliability of CI is the best and SPI is the worst. And bargaining power is another important fact which will influence our choice. We can judge this based on 3 aspects. The first one is brands and quality of suppliers, because CI is well known for its broad capacities and good quality. So CI has stronger bargaining power than SPI because it has poor quality, so it will has weak bargaining power. And the second aspect is the revenue of suppliers. We can calculate raw material cost and labor cost based on Excel, and we know the per unit price quote of every supply, so we can calculate the revenue of every supply. And we know that if a supply has less revenue, it is more reasonable for it to bargain. So we can find the bargaining power of SPI is stronger than JI, and the bargaining power of JI is stronger than CI. And the third aspect is the switching cost. We know that if supply it has greater switching cost, it is difficult for us to move from this supply to another one. And after calculation, we can find that the switching cost of SPI is greater than CI, and CI is greater than JI. So in summary, we can conclude our analysis in the table below, and we can give a point to every aspect. And after calculation, we can find that the bargaining power of SPI is the strongest, and the JI is the weakest. And because if a supply has stronger bargaining power, it will definitely do harm to us. So to GM, JI and CI are better options for us. And so let's make a conclusion.
So based on the analysis above, although the cost of a CT6 VA option is lower than Tier 1 by just about 5%. So considering about quality, reliability, and bargaining power of a VA option, we think that the Tier 1 option is the right option for us to become our final decision. So, however, we have met a new situation here. There is something wrong about the connector. So, let's figure out how to deal with the problem.
Now there's a problem happens in the supply chain. We have worked with CI, but there's a connector that is not suitable for the cockpit. So that will make a huge damage to us since we have to stop our production. Here's the questions: how long should we stop the how long will we have to stop the production of CT6? Maybe 1 day, maybe 2 days, maybe 1 month. But the key point is whether we can use the current inventory. And I think from the engineering solution, we need to rework the current inventory. Number one, CI needs to stop. Sorry, there's some problem. DHAM needs to stop ordering the wrong connectors. And next step will be we need to work with CI together, and we should set a team of engineers to cooperate and work and figure out whether it is possible to correct the cockpits already assembled with wrong connectors. I think it may be an engineering problem. I don't know whether it can rework the wrong connectors, but I think someone will figure it out because we have so powerful engineering talents. So it is very important for us to use the current inventory to deliver the production. And number three, I think we should put some engineers in CI to modify the connects in the warehouse as well. So the general point is that we need to rework the current inventory. We can't just abandon them. We can't just stop the production and take no measures. And that is the immediate action. And now let's move on to the long-term action. The number one we have to do is to make our engineering can design the perfect connector that is suitable for the cockpit. So we have to do is make our engineers to redesign the module. And I think that is not the only responsibility of GM or CI or the T2 supplier. It is all the responsibility of us. So we need to get everyone together and figure out if there's a design problem in the original step. And number two, if the engineering change period is too long, then we need to cut down the transportation period. I think transporting by air is recommended, since the lead time now is about 30 days. That is too long, and we can't wait so much time to receive the correct connector. So I think under this situation, transporting by air is recommended. And then there's another problem. Who should be responsible for this big problem? I think we need to take a serious view into every details of our process. And that requires us to communicate with CI to identify the source of the problem and find out who is responsible for the fault and who should cover the total cost. Since the production has to stop anyway, so we have additional cost. For example, the rework cost, the redesign cost, the emergency transportation cost, and the production lag cost. So we should work together to find out who is responsible for this cost. And let's move on to the future precaution. We need to stop this problem happening again. So we have to identify the potential risks and fix it. I think we have to find a second tier 2 supplier to supply connectors to reduce the risk. Now we only have one tier 2 supplier to supply the connector. And once the problem is happen, we can't immediately find a second supplier. That is very dangerous, since it needs time to start a relationship with a new supplier. So if we can start to talk with a second supplier and make a second contract, maybe we in the future, if the same problems happen, we can reduce the risk, and we don't have to rely to just one supplier. So that's the point. And next step we have to make is to keep a safety inventory of parts that requires a long lead time to buy. In this case, we need 30 days to buy the connector. This is a very long time, so we need to ensure that we have enough inventory to produce the CT6. Once there's a problem with the transportation or with the production in tier 2 supplier, and in that case we can respond more quickly. And so I think we have to keep about 2 weeks inventory. If the order happens to have something wrong with it, then we can have the 1 week inventory that can still used. So I think that is very important to keep a safety inventory.
You have just 1 minute.
Okay.
So, thanks for watching. That's all.
No, you're all done.
Yeah. So thanks for watching, and because we didn't have any experience about how the supply chain of the vehicle works, so we tried our best to figure it out. So thank you.
Timing is everything.
Very nice job. Thank you. I just have a couple of questions. A couple of your mitigations included dual sourcing of components along with building a buffer or safety stock levels. Help me understand what factors you think need to be considered when you dual source, and then also what factors should be considered when you build a buffer.
I think the key point is that we should reduce our risk. And so I just said that we can cooperate with 2 suppliers at the same time, so we can reduce our risks when we are sourcing. If one supplier is going wrong, we can rely the second suppliers to respond quickly to the crisis.
May I follow up on that question? So the suggestion is that we'll dual source and we'll carry more inventory. What does that do to your cost? I don't want a specific answer, but which direction will your cost go if you in fact dual source and carry more inventory?
I think we should consider the inventory cost and the safety and the production the safety value required by the production. At the same time, we have to consider the 2 factors at the same time. So I think we should just put the 2 factors together, and there's not so much information in this case. But if there's for example, the transportation fee and the ordering fee and the cost of each component, then we can calculate that whether which volume we should order every time.
Let me interrupt you a second. So the question is, if you bring on a tier 2, one more supplier, what about the cost impact of that?
Thank you for your question. I think that maybe if we choose a second tier 2 supplier, it will sure to weaken our bargaining power to our supplier. So maybe the cost will be component cost or assembly cost may rise up, and maybe we may have more solid relationship if we are just cooperate with just one supplier. So I think it's a relationship, and maybe some long-term investment may just yeah. And we should also consider switching cost from one supplier to another supplier. Thank you.
Thank you.
I, I don't have so much a question but a comment, and I would say that I was very impressed with your financial analysis and your strategy analysis. I think you were very, very thorough, and you did an excellent job in regards to that.
Can you go back to the conclusion or your recommendation slide for the first part of the presentation? And the question back further, or I guess this is fine. I guess so you're recommending tier one, T1, so I'm assuming that is CI, is that correct?
Yes.
Okay. Did you decide to do anything with the EREV product or any others? Because one of the challenges here was reducing complexity at the site. Is there anything else you included in your recommendation beyond going to CI for the CT6?
I think we can, beyond consider CI for the supplier for CT6, we can also consider SBI, but we should consider to shuttle again with both Malibu, Impala, and CT6 because we found that the shuttle cost is too large, and I think it is. I think if we just shuttle CT6 or EREV, I think it's a waste. Yeah, I think so. So I think we should cooperate them together to transport from SBI to DHAM. Thank you.
Okay. And then the second on your analysis on the quality, and I've mentioned this to the other groups too. I like the action plan you put in place, both short-term and long-term, relative to how you get to root cause of this problem. One of the things I've suggested to the groups is, since this is a matching of one connector to another that's created the issue, the basic assumption in the case is that it is the connector coming from tier T2. In reality, you may not know. It could be the other connector, you know, so you brought the engineers together. That's the appropriate action to take, because in a situation like that, they'll want to look at which half of the connector really is causing the problem. Because it could, what you don't want to do is go resource T2 when you find out it's really the other connector. So I like what you put together. What wasn't clear to me is when you face that situation, you're now making a recommendation to supply chain. What are you going to do with current production? You now have a bad part. What actions are you taking with your current production as you're working through these different strategies? Immediately, yeah.
My key point is that we now have the inventory of the wrong connectors. They are not suitable, but we can figure out how to rework them. We can modify them, and so they can suitable for the cockpit. That is our immediate action, and immediately we should find out how we can create a perfect connector that is suitable with the cockpit. So we have to set a team of engineers to figure it out, and so we should put the lead time lower, and we should receive the correct connectors as soon as possible. But before that, we can use the current inventory, even though they are not suitable. But we can rework them. We can modify them, and so that we won't have to stop our production for a long time.
Thank you. Good job.
Okay, thanks very much, team. Nice job.